In an earlier example, I took a look at how we could do equality with a string. Now, while that might be what we're looking for when it comes to, say, like a last name or a name of a region, more commonly, what's going to happen is my users are going to be doing a search for a particular item where they know part of the name, but not necessarily all of the name. The way that we handle this is by utilizing a like statement. A like statement will allow us to put in wildcard characters, where a percent sign will mean 0 or more characters, an underscore will mean specifically one character, a set of square brackets will allow me to indicate a specific range. So if I said square bracket AFR, and then close square bracket, that would look for A or F or R. And if I did in square brackets A dash F, that would look for anything in that range. So it'd be A or B or C or D or E or F. And then finally, if I put in a set of square brackets and I start off with a caret, that's actually going to look for any other character than what's listed. Now the square brackets, you'll notice the behavior is very similar to regular expressions. SQL Server, however, does not support regular expressions. So if we come back to our query, let's say that I'm looking for all products that start with the letters of MOU, which is going to be short for mountain. So let's go ahead and say select, let's say the name, let's say the list price, and let's say where, whoops, let's not forget our from line, from production product, where name, like, and then MOU, and then we'll put our percent sign at the end. And that will give us every single product that starts with MOU. Now it is possible to put a percent sign at the very beginning as well, which will then look for MOU anywhere inside of the string. You want to be very careful about this. The reason for that is the way that SQL is then going to retrieve your data. The only way that SQL has of going off and finding that data is looking at every single item. Imagine, for example, that you are going to grab a phone book and you are going to look for every single person that had the letters MOU somewhere in their last name. The only way that you'd be able to do that is to look through every single page inside the phone book. Well, SQL's the exact same way. The only way that it's going to be able to do this is by looking through every single row. So as a best practice, never start with a wildcard character. One last little thing to note about doing a search with wildcard characters is the fact that you will want to provide as many letters as possible. And again, this has to do with performance. One of the things that can wind up happening behind the scenes is that if I just simply did an M, SQL might decide that it's going to get back so many rows that it would be easier just to look through every single row. A good basic rule of thumb is about 3 to 5 characters at a bare minimum. Now, of course, the number of characters that are going to be required is going to vary based on the query, based on the data, but that's a good rule of thumb of making sure that you've got at least 3 to 5 characters whenever you're doing a like search for data. One last little note on like is you do have the ability to put in an escape character. So that way, if I needed to specifically look for something with a square bracket, I'd be able to indicate that with an escape character. Now, unlike other programming languages where an escape character is predefined, SQL gives you the opportunity to define your own escape character. And the way that you do that is by using the keyword escape and then indicating what the escape character is after the like statement. Let's turn our attention to null data. Let's talk a little bit about how our predicates are going to be evaluated and then what's going to happen with null data. Now, believe it or not, predicates have actually 3 possible return values, which is very different than most other programming environments. Normally, it's just simply true, false. Well, in SQL, it's true, false, and unknown. Now, the reason that we have an unknown is because of null values. That SQL is never going to return true or false whenever we're doing anything that's going to compare a value to something that is null. For example, let's say that we had two little items. We had x, and x happens to be null, and we had y, and y happens to be null. Well, if I ever said that x is equal to y, if I return that as true, now I've defined something for that null value. What I've now said is that x is equal to y. And if you remember, a null value is the great unknown. We don't know what the value is. We don't know why we don't have a value. We don't know anything at all about it. So if we did anything that constrained that value, now we're providing something about it. So if we later solve for x, and we now know that x is equal to y, then we also know what y is. Doesn't maintain what I like to call the sanctity of a null. A null value must always be a null value, must always remain that great unknown. And that would also be true if we did a less than. If I say x is less than y, then again, it's the exact same thing. That if I solved for x later on, if we later decided that x is 42, then we now know something about y, that y must be greater than 42. So whenever we're dealing with null values and any normal comparison operators, SQL will always simply return unknown. Now, when we create our where statement, only rows that return true are going to be returned. Anything, again, involving null is going to be unknown. So if I come back over here and I create the following query, let's say select first name, last name, and then our middle name from person contact, where my middle name is equal to null, what you're going to notice is I'm going to get back 0 results because it can never actually equal null. You'll also notice that if I put in a not statement in front of that, and not, of course, is going to reverse the value, you'll notice once again, still no values are returned. Because this middle part right here that's highlighted, my middle name equals null, that's going to give me back unknown. And the reverse of an unknown is unknown.